Hi everybody, today we're going to be working on lesson 5, linear regression on the calculator. So before you get started, make sure your calculator is charged and ready. You absolutely need your calculator throughout this lesson. You need to practice, what buttons to push and how to move your way around. All right, so our objective is going to be to use linear regression feature on our calculator to create linear regressions. And the first thing we need to learn about is a scatter plot, and that's a graph that relates two different sets of data by plotting the data as ordered pairs. When we have a positive correlation, it means as x is increasing, y is increasing. So we'll say as x increases, y increases. The more I study, the better the grades I get. Right? A negative correlation occurs when we have x increasing, and as x increases, y decreases. All right, so the further you drive, the less gas you have in the tank, right? As x is getting bigger, as the miles are increasing, the volume in the tank is lowering. Now, no correlation occurs if x and y are not related. They are said to be independent, so they have no correlation. And when you looked at these first two scatter plots here, it's really clear that, our scatter plot was increasing. And if we drew a line through the center of the negative correlation, it was decreasing. But you're really not quite sure where to draw a line when you don't have correlation. And that's when you're really sure it's an independent data set. The line of best fit is a line that approximates the relationship between the data sets of a scatter plot. So in other words, when we're drawing that line, we're going to use the calculator to help us find the best fit line through the points. Linear regression attempts to model the relationship between two variables by fitting a linear equation to observed data. Linear regression finds the equation of the line of best fit. So if we have some points, let's say I'll just do a little random, and we want to know what line would best represent those points. We'll go through them really perfectly with, just the perfect amount of points above and below and following the direction. We're going to use our calculator to come up with that line. You can use your graphing calculator to display data sets, draw scatter plots, and draw a line to fit the data. The line is the linear regression line, a line of best fit. The linreg feature on your calculator fits data to model y equals mx plus b. The correlation coefficient R tells you how well your regression equation truly represents your set of data. The closer the correlation coefficient is to either plus or minus 1, the better the line of fit. A correlation coefficient of exactly 1 or negative 1 means that the line is a perfect fit to the data. And we're going to practice some examples to make sure you're understanding exactly what do I mean by this. Now, really important at the start of this, and I'm not with you to help you with this, so make sure you do this or you're going to be really confused. We need to make sure diagnostics are on your calculator, right? And I'm going to turn diagnostics on. So if you notice, there's on the 0, there's a catalog button, but the catalog on my calculator is in blue. That means I have to do second 0 to get to the catalog. And as soon as I did that, up in the top right corner of your calculator, you'll see the letter A. That means alpha has been turned on. That means I can press any letter and it'll take me to that. So I'm going to press the letter D. All right, I'm going to find the letter D. I'm going to press that, and that'll take me right to the D words that are in my catalog. So I'm going to press that button. Now I'm looking for diagnostics on. So I'm just going to scroll down here using my arrow key, and I found it. Once I'm there, I'm going to hit enter, enter. Okay, now if I went too fast for you or you didn't get it, rewind and make sure you make this happen, or you're going to be missing important values as we go through the process for looking at linear regression. All right, hopefully everybody is good. So now we're going to learn how to use our calculator to find the line of best fit for a set of data. Now it's really good practice to clear all your lists before you begin. So we're going to do that. And I have the steps here, and I'm also going to show you on the calculator. So we're going to go to second plus sign, and we're going to choose number 4, clear all lists, hit enter. All my lists are clear. Okay, so far we got this, we got this. Now we're going to enter our data into lists. I have the lists right here for you. All right, we're going to go to stat, enter, stat. And remember, the buttons are being highlighted in red as I go to help you find things a little easier. Once we're in our lists, we're going to enter our data. So you would enter 7, you'd hit the enter button. We're going to go over to list 2, enter that data. We exited the list by doing second mode. Now we're going to calculate the line of best fit. And when you do that, you want to make sure you're on your home screen. So second mode to get back to your home screen. All right. We're going to calculate the line of best fit. So we're going to do stat calc number 4. Right? Don't do number 8. So let's go look at that. So we're going to do stat calc number 4. Now, some people get confused and they use number 8 by accident. We don't want number 8. We're looking at linreg only, number 4. It's going to ask you, where's your X list? That's in list 1. If nothing is there, you would do second 1. So you would say, you would do the second 1 button to get list 1. Hit enter. List 2, we would do second 2 to get list 2. We should have nothing in the frequency list, all right? And we should have nothing in the store regression. We're going to hit calculate, and we just came up with our line. All right, so it looks like it's going to be y equals, our A value is 1.06 plus 1.06x plus our B value is about 1.18. And we're looking at our R value. If you have diagnostics on, you should see that R value, and that's approximately 0.93. Right, so let's enter that where we have a place for it on number 4. Now, remember we said that R is the correlation coefficient. The closer that value is to 1, the better our line fits our data. So we almost have a perfect fit for our line to our data. Right, the next thing we're going to do is we are going to create a scatter plot of our data. All right, so we're going to turn stat plot on. All right, and I'm going to do that on my calculator, and you have the steps in front of you on your notes. So we have to go to second y equals to get to stat plot. We're going to hit enter, and you can see step number 1 for creating a scatter plot shows you what you should have highlighted here. We want the on button highlighted. We want to make sure we're highlighting the scatter plot, and we want to make sure that list 1 is our X list and list 2 is our Y list. All right, once you're sure that everything looks good, we're going to go ahead and do zoom 9. And there's our scatter plot. Okay, so we've created the scatter plot of our data. And now what we're going to do is we're going to add in the line that we believe is the line of best fit that was given to us by the linreg feature. Right, so let's go back to our notes here. We want to make a note that we did this. We saw our graph. And now we're going to draw the line on our calculator. So we are going to add in to our y1 the equation that we got. And the equation we said was, let's see, it was 1.06x plus 1.18. All right, let's go to our calculator. We're going to go to y equals. We're going to enter 1.06 x plus 1.18. All right. And we're going to press graph. And there we go. We can see how our line is cutting through our points beautifully. It's in the center, and it fits our graph just the way we want it. All right, now this is really the whole point to modeling, right, is to make predictions. And as you know, in recent times, there's been a lot of talk about modeling and predicting what's going to happen in the future, right? So if we have a model that we feel is very accurate, we can say, well, you know, what happens when we get to a different point in time or we have a different X value? What would we predict? You know, what would our model predict? So we're going to calculate a value for y given an x, and we're going to use the second trace value feature of our calculator. So let's go back to that. We're on our graph, right? We're going to go to second trace to calculate a value. And in this case, we're being asked to find what will y be if we put an input value of 3. And we get 4.36. Okay, so based on our model, that's what we think the value would be if we had an X value of 3. Now, some people pick up the calculator steps very quickly. Other people need a lot of practice. So if you're feeling frustrated right now and I went a little too fast, just go back and walk through the steps again. It's only going to take about 5 or 10 minutes and will really help you feel a little bit more confident. And also, you know, you can come back and watch this video anytime just to kind of remind yourself how to work through all the steps. All right, so we have a practice problem here. What I would suggest is you try to do this on your own, and then when you're ready, come back to the video. For the given data set, calculate the line of best fit, sketch a scatter plot using your calculator as a guide, sketch the line of best fit through your scatter plot using your calculator as a guide, and answer the prediction question. So in the following data, X is chirps per second for a cricket, and Y is the temperature in degrees. So basically, depending on how chirpy the crickets are, can tell you a little bit about what the temperature is in Fahrenheit. All right, so let's see here. Let's put this data into our calculator first. So I'm going to quit out of this screen. I'm going to clear my lists because I'm starting a new data set. I'm going to stat, I'm going to go to edit. I'm going to enter my data. Once you have your data entered, it's just really good practice to take a moment and look back and make sure you didn't make any mistakes, or you're going to get really frustrated because one little mistake can mess it all up and you'll get a completely different answer than everyone else. So just double check you have the right data entered. Okay, I'm going to quit out of there. And now I'm going to use my calculator to find my linear regression model. All right, so I get y equals 4.19x plus 8.19. And my r value is 0.92. Good, it's a good fit for my data set. My next step is to look at the scatter plot. But before I do that, I want to update the equation I have in y equals. I have my equation from my last problem, so I'm going to clear that out. And I'm going to enter the new equation that I just got, 4.19x plus 8.19. And I'm going to do, to fit my graph to my data, zoom 9. That's what your data should look like. And we're going to do a very rough sketch, a very rough scatter plot on our paper. Now the last question here says, what is the approximate temperature in degrees if the crickets are chirping 15 chirps per second? Right, so let's go back to our graph and we're going to do second trace. We're going to enter the value of 15 and hit enter. And we see that the Fahrenheit temperature should be 71.04 degrees. All right, so that's everything for this lesson. Take your time, go through it slowly, practice. The more you practice this, the easier it'll get. Have a great day.